Do it now.
No.
Okay, doesn't matter. We can. So that is a little bit of the, how to say, this is kind of recap of the electricity.
Mm-hmm.
Do you know, can you explain to me this idea? Just make sure you understand, apart from electrical charge.
Which
How about
idea?
how about the force, electrical force, statical force?
That is E equals K Q over R squared, right?
Ah, you're talking about Coulomb's law, all right?
Mm-hmm.
Yeah, you can write Coulomb's law. You can write down Coulomb's law. Two charge, right?
Yeah.
It's two charge. Okay, have you applied this Coulomb's law before?
Mm-hmm.
You did?
Yeah.
Yes. For example, can you work out this force acting, for example, you have the, can we have this hypothetical, can we just have consider they have the one positive charge over here and one negative charge here, which is the same distance, right?
Mm-hmm.
And there's another charge also positive here. Can we say this is just make sure you have done this before. So this is a positive Q, this is a negative Q, and this is a capital Q. Can you work out the force acting on these two units? So this is 1 unit. So this is -1, 0, and this is +1. I'm talking coordinate. This is 2, this is 1. This is the y-axis, this is the x-axis. Can you work out the force acting on the Q? Can we try this one? Find the force to determine the electrical force, electrostatic force on the charge Q. Can you try?
Mm.
So that is how to apply Coulomb's law, right? Isn't it?
Mm-hmm.
Yeah. Okay,
Yeah,
the distance is square root of 3. Yes, good idea.
Is it? No, it's not square root.
Oh, 5, is it? 5
yeah.
Should be 5. 5 square root 5. That is distance, okay. So what is direction of force between these two pair?
So this one, it is positive. For that one, it's repulsive.
It's not positive. It's, you have to consider the direction. Yes, this is positive. This is negative, and this is also positive. Sorry, this is also positive. Capital Q is positive. What are these arrow? What is it, the blue arrow? What does that mean? The force?
Yes, because when you draw electric diagrams, the negative force always goes in.
No, this is between the two positive charge. The force is not attraction.
Isn't negative? Oh, it's okay. I see.
Yes.
Yeah.
Be careful. Yes.
I thought that was the charge.
Well, depending on what you're trying to draw. Now, as I said, when you draw the force, please just, yeah, that's right. Please draw make sure that the force is acting on the point. So here we have two ideas. This have point charge. If you talk about point mass and point charge, then we have put the force acting on that particular charge. That's what the Coulomb said. You want to substitute the numbers now. But before that, can we work out the force? Can I show you the force between the first pair acting on the capital Q, that direction? Do you agree?
Yeah.
And the force between the second pair, it goes that direction, right? So you need to find the sum of these two.
Oh, okay, yeah.
Yes. So we better to make the tail starting from the point. Yes. Okay. You can shift that, right? Okay. Yeah, that is E. Which E? Which is E? That's right. We're dealing with the sum of two vectors. Yeah, that's right. That is a diagonal. That's right. That's diagonal. Yes. Does that E simply equal to this number or not?
Pardon?
Do you think this is answer now?
I
I don't think so, because we have calculated this one by one. This first one, can we call this is fourth one? Can we call the fourth one? Besides, I'm asking for the force, static force. So I'm looking for the F. If you use the net, we're looking for the net force. Can we call this F1?
Yeah.
And this F2?
Mm-hmm.
How can we find the force? So the net force will be the vector sum of these two. So be careful, you have to work out the F1 and F2 separately first. Not just the magnitude, but also the direction matters. Yes, oh yes, I noticed your teacher used this notation, right?
Mm-hmm.
And did you use R?
Yeah.
This vector, that is the best mathematician's notation. Okay.
This is what my specialist has taught us.
Yeah, that's right. And it is Math C teacher. Okay. Okay, you know the theta, and you know the distance. So what is F1? My question still what is F1? What is F2? I agree. I agree. The interdistance between these two pair is R. Can you call it R? Yeah, that's R is root 5. Yes, I agree.
Close.
So what is the theta in this case? In this diagram. Aha, this is theta. Okay, you need to find the theta. Up to you. It's 2. Yeah, tangent to 2. Yes, very close to 60 degrees. All right. We know theta, we know R distance.
So
Number. Where do you get this distance formula? F1. Did you apply the Coulomb's law or not?
no.
Why don't apply? Why not? Why don't apply Coulomb's law to work out these two forces? This is not Coulomb's law. What are you trying to do? I'm not sure now.
I don't know the charges of.
Charge is just numbers. Doesn't matter. Eventually, I can tell you the numbers. For example, we can we can give this particular number, say Q. In this example, can we put the Q here? If you did numbers, so can we just giving Q is equal to 0.5 multiply microcoulombs. Capital Q is 1.5 multiply just micro, not multiply. It's microcoulombs. Just microcoulombs. Are you trying to work out E or F? So you see, when that's why it's not a good idea to jump to the magnetic field. There's a difference. One is force. Can you see? One is a force. Another is a field. It's different idea. But be careful. In this case, we are looking for the force, not the field. And besides, this is not right. If this is for the electric field, you have to cross one of the charge. You see that? The Coulomb's law, can write Coulomb law here. The correct Coulomb law is F equal to a constant K multiply the two charge divided by their distance between the 2 points.
Yeah.
And for electrical field, we're not going to use in this problem solving, is that E for each charge can be written as a Q divided by R squared. If that is for single point charge, but we are not going to use this formula here. So be careful. We are looking for the force, not the electrical field.
Yeah.
You see, we are looking for the force, not the electrical field. So, I noticed many students just use the numbers, plug number in the first place, but we haven't found why don't we find the formula first for the net force? Basically, the essential question is this: we need to find the net force, both the magnitude and the direction of the sum of the two electrostatic force. How can we do that?
Isn't it just times 2?
Yes. Can you just put it together? Yes, because that's very important. We are starting the vector in math, right?
Yeah.
When we started two vectors, you can only do this sum if these two vectors are parallel. Can you see?
Yeah.
If the two vectors are either parallel or anti-parallel, we can use the sum or difference, right? In this case, we can use the sum. Or in other case, for example, if this is one of them is anti-parallel, then we have used a difference, right? And this is a special case when the two vectors are on the same straight line. But in our case, the two vectors are not on the same straight line. Therefore, we cannot simply use this formula. Can you see?
Yeah.
This is true. Yeah, go on.
Is it a cross product of them?
Oh, they have nothing to do with the cross product. This is a sum. You see, when we studied the algebra, we studied the sum. We studied the difference. After that, right? We studied product. Okay, and then quotient, and then quotient. Okay. That is the full rule. But here we are just starting. We're not go to the product. We are just starting the sum. Can you see?
Yeah.
Not the product. We are not interested in the product this time. So you have to really think how to work out this side. How can we find this side? And we know that direction will be parallel to the x-axis, all right?
Mm-hmm.
Because these two forces must be equal in magnitude, but different in direction. Do you agree?
Yeah.
Because in terms of magnitude, can we give you a help? So I wouldn't consider about this at this stage. So what I need to do is we need to find the magnitude, right? So both F1,
Yeah.
in terms of magnitude, they are equal. Do you agree?
Mm-hmm.
This is magnitude. They are all equal to Q, small q, capital Q, and 5, right?
Mm-hmm.
Root 5, because in this case, and R equal to square root of 5. So therefore, R squared equal to 5. Do you agree?
Yeah.
So this is our equation 1. But now we have used our geometry to work out this side, given these two sides. Can you see? Perhaps I will help you to redraw this part, all right?
Mm-hmm.
I will help you to, because it's very important to make sure we know that we are dealing with the sum of two vectors, not just that's just a scalar sum or difference, right? So what I can do, I can draw the, wait a minute. Okay, 1 moment. Just clean up this side. Okay, then I can draw a proper parallelogram. Okay, one is this direction. Oops, do it again. This one is direction parallel to the second one, you see, and another one is this one. So therefore, we can, in this case, we can find the net force. Can we use different color? So the net force should be go that direction. Can you see?
Mm-hmm.
In other words, if because this is a parallelogram, we know that this side must be also equal to these two. Can you see?
Yeah.
So the unknown side is this side. Do you agree? So this side will represent the force, net force amplitude.
Yeah.
Got it?
Mm-hmm.
So how can we do it? We know two sides and we don't know the third side. It's becoming geometry problem. You agree?
Mm-hmm.
But we cannot simply put the sum together. We can't. Yes. Yeah, you got the angle. I just give you, yeah. Since you got the angle here, this is a step forward. Can you see? You know the angle. Do you agree?
Mm-hmm.
Not this one, not this is wrong. So this is correct. Okay, we know the angle. If you know the angle, how can we work out this side? Mathematically, it's not physics anymore. It's a mathematical problem now. Do you want to use cosine rule or 2AB? Right.
Oh, 2AB. What's the cosine rule?
Which angle do we know?
63.43.
Doesn't matter. You can apply. You can write it down. So basically, the yellow color is the length of this yellow line is unknown to be determined.
Mm-hmm. So Jason overhead put me.
So if you want to choose as theta, then you have to how to say? Yeah, you decide. It's just math problem now. I think you need to find this angle if you want to consider C is net force. Do you consider C is net force?
Yeah.
And then you need this alpha. Can you see? You need this alpha angle, this angle. You agree?
But we could always just.
You can use a projection twice. Yes. Have you started projection now? Not yet?
No.
Okay, you can use a projection. Yes. you can project these two onto this direction. Yes, that is another way to solve that by projection.
Mm-hmm. Mm.
You need help?
Yeah.
Yeah, so basically, if I just write down here, so the total force, if I use projection, all right, if we just we have used projection before when we started the Newton's law. Do you remember? So the net force will be equal to 2 times of the projection of either F1 or F2 and the cosine theta. Can you see? Both F1, F2 will give the same projection. That's why we have to multiply 2 here. So this is our second equation. Okay, this is your third equation. So if you put them 2 together, we should be able to work out this one. Okay.
Yeah.
So that would be equal to 2 K Q divided by 5 and multiply cosine, whatever number is 63, 63. Is degree, the degree? Oh, roughly, that would be enough, accurate enough. 4. Can you see the answer now?
Yeah.
That is just magnitude. So be careful. Don't use this formula, okay? This is only true in this special case. Can you see? You can use this special case, but not in our case. So when you find the sum of the 2 vectors, you have to use geometry, all right? Or you can either use geometry or use cosine rule or projection. Yeah. Okay, I think we will do more exercise. Do you agree? And I don't think, but obviously you have learned some, formula about magnetism already. But perhaps we also need to do some electricity. Yeah, make sure what electricity is. All right. Yeah. Okay, I see you next week. Okay.
I'll see you next week.
Okay, goodbye.
Thank you. Goodbye.